Welcome to another installment of the Consulting Specifying Engineer video discussion. I'm Amara Rozgas, and today we're talking HVAC, specifically indoor air quality. IAQ quantifies the minimum acceptable air quality that promotes health and comfort of the human occupant. And today we're speaking about the Indoor Air Quality Procedure, or IAQP, which is part of ASHRAE 62.1. I'm here with Zachary Everett from Daikin Applied, and we're talking about topics mechanical engineers would be interested in. Hi, Zach.
Good morning. Thanks for having me.
So here's a bit of background information about Zach. Zachary Everett started his career as a mechanical engineer at a global medical technology company. He then moved into the HVAC industry and has been with Daikin Applied for almost 9 years, working as a project manager and currently as a field sales engineer. He holds a master's degree in system engineering from Stevens Institute of Technology in Hoboken, New Jersey. So Zach, I have attended several presentations about this topic. We've covered it in Consulting Specifying Engineer in many ways, so let me dive right in here. The ventilation rate procedure in ASHRAE 62.1 has been the dominant method of determining the amount of outdoor air needed for acceptable indoor air quality. Why is now the time to reconsider how we are ventilating buildings?
Yeah, I think that's a great place to start. We've been doing this since 1981. We've been making our ventilation calculations using, as you said, the ventilation rate procedure. Primarily, operable windows or the natural ventilation rate procedure went out the window a little while ago. And we've been moving forward with this prescriptive, basically CFM per square foot and per occupant, and then leveraging that space type and just coming up with that final calculation here for 30 some odd years. So I think to your question, why is it that after all that time in an industry that gets comfortable with something like a procedure and continues to use it until there's significant innovation, why is it that we have decided to start the conversation anew? ASHRAE brought forth a series of addenda last year in 2022 to the ASHRAE 62.1 ventilation code. And that has really changed the game from a liability standpoint and allowed us to take advantage of something that's been there for that entire 30-year period. So I think that when we begin to talk about the IAQP, we talk about all these changes first. And I know that it's a topic that, to your point, is discussed regularly, but it's not something that is necessarily being pushed by one manufacturer or another. It's just something that ASHRAE has finally brought us clarity on. And so we've begun at Daikin to look at all these different addenda and say, okay, how can we leverage them to further our industry? How can we kind of take the driver's seat? We've partnered with a company called Everett to bring sorbent ventilation technology to the forefront of the conversation. So I think that there are a couple different pieces, companies like Everett bringing gas phase air cleaning forward, as well as all those changes that were made to the IAQP really change the game and allow us to focus more on doing calculations in a less prescriptive and more space-specific way.
Okay, so specific to these calculations, is that something that needs to be done by the engineer, or how is that handled?
Yeah, the changes that were made last year, they gave us clarity in the 14 VOCs that are specifically being solved for. So these are the contaminants of concern that ASHRAE says in each space we need to make sure are at our set concentration limits. They also publish those concentration limits, as well as some off-gassing information and a better way for us to bring our outdoor air quality understanding up. So all those things factor into this mass balance analysis equation. But this is not something that is complex. It's actually something that can be done through a calculator that has been available from different manufacturers. But ASHRAE is in the process of bringing this calculator for the IAQP forward in a similar way that they have the ventilation rate procedure calculator available on the website. So that's actually through public review. and we anticipate that it'll be published in the very near future.
Okay, so my next question, we actually touched on this in a webcast. Huge topic of discussion. What level of efficiency savings is possible using IAQP? And then how is energy recovery being paired with IAQP to maximize these energy savings?
This is where we start to see a really strong argument for the IAQP. So when we take these new data that have been introduced by ASHRAE and implement them into our calculator, we're given the IAQP ventilation rate. So here at Daikin, we would take that ventilation rate and we would partner with our company in Everett that we have been working with directly for gas phase air cleaners. And we would begin to design for the job specifically. So the payback analysis that needs to be done and the benefit that we can see from the change of procedure really comes in on a job specific basis. And so those efficiencies, I will give a couple examples of where we see them fall broadly. But I think that it's important with the indoor air quality procedure to understand that we are reducing the ventilation that we're bringing in from outside, but we're not necessarily reducing the supply air to the space. And so I think when we start to look at efficiency savings, it's really important to think about what air we're actually treating in the largest quantities. So when we look at the numerator of that IAQP calculation, without kind of boring everybody with a full mass balance analysis equation, we have the ability to subtract air that is processed in the return air stream by some sort of a gas phase air cleaner. So in Daikin's case, that would be the Everett air cleaning device. And that allows us to significantly reduce our reliance on the outdoor air as a whole. So while we still will bring in some air for things like pressurization, we're able to subtract out that air that's cleaned in the return airstream directly. And that's really where we see that efficiency start to shine. So your question, I think, had two parts. So where do we see the efficiencies is the first piece. And then is this a competing technology with things like energy recovery, or is this something that we put all in one? And I think as we start to break down the efficiencies, we start to see a pretty significant 50% or so savings, even from the VRP, when we introduce something like energy recovery. So that's something that we've had in the codes for a long time. We've always had thresholds, and we make sure that we leverage that technology to better our world. When we start to shift the conversation to the IAQP, we see about a 65% savings off of baseline energy just for the ventilation specifically. And that really is dependent on the project, on the space, just like the VRP is dependent on the space itself. But as we start to look at that savings in energy, I have an example that was just published as an article in ASHRAE, and we can put that certainly in the footnotes here. But it showed a 65% savings when you start to leverage the IAQP and something like Daikin's sorbent ventilation technology that's made by Everett, or any other gas phase air cleaner that does something similar with similar efficiencies. So that was 65% savings. And then to directly answer the question on energy recovery, we actually see almost an 80% savings over baseline in the ventilation data when we're leveraging the energy recovery and we're leveraging the sorbent ventilation technology or something similar in the gas phase air cleaning and the IAQP as a whole. And so that's based off of a study that was done for ASHRAE 241, which is kind of like a whole nother topic of conversation here as we start to talk about pathogen mitigation and making sure that we have appropriate filtration. But the savings can be very, very significant for the IAQP, again, depending on the space, specifically the space type. So I think that it's important when we talk about the IAQP to not talk as broadly as we might have in the past with the VRP, which is the more prescriptive calculation. The efficiencies are certainly there, but when we start to have our business owners look at the payback for implementing a technology like this, we need to break down the IAQP, the storm ventilation technology, and then the savings as a whole. Because I think that decarbonization is a really important driver for our industry, but we are also obviously going to have to factor in first cost. And that paper that I referenced does discuss first cost of these installed systems as well for an elementary school, actually.
Okay, so let's apply this. Let's put this into practice for mechanical engineers. Can leveraging the IAQP affect final system size, and what happens on design day if tonnage is downsized?
I think that this actually gets into a pretty common misconception with leveraging the IAQP and specifically gas phase air cleaning in general. We are going to reduce the tonnage of the system, but that's because we're reducing the reliance on the outdoor air temperature specifically. So on those design days, I'm sure that your audience is well aware, we're designing for our worst case scenario, right? So in many locations, that's 95 degrees, it could be 0 degrees. And we're making sure that we're able to, at those most extreme temperatures, handle the entire cooling or heating load. And I think that when we start to talk about the IAQP and downsizing, quote, downsizing the tonnage of our equipment, people are concerned that we won't be able to handle those extreme temperatures, the very high highs and the very low lows. In this case, we're actually making our system a lot more resilient because we're able to only have to process a certain volume of that very high temperature air or very low temperature air. And instead, we're taking advantage of that gas phase air cleaning in the return airstream specifically. So when we're doing that air cleaning, we're really not touching the air that is, quote, fresh, that's being brought in from outside. That's what we used to call it, even though in the VRP, that air is not necessarily fresh. It's just whatever is outside at the time. So we're able to reduce our reliance on that outdoor air and therefore downsize the tonnage without affecting the functionality of the system, even in the most extreme temperatures. And I think that that really summarizes nicely the whole story. We can take advantage of these changes that were brought to us by ASHRAE. We can, with confidence, move forward using their calculator that they're going to publish. And then we're able to really directly affect the efficiencies of all of the systems that we're implementing this on. And at the end of the day, we're really able to also affect that decarbonization effort, and we're able to downsize the tonnage of our systems as a whole. So there may be first cost savings there, depending on the project. There may be long-term savings there, depending on the efficiency change in the project specifically. But overall, we're able to confidently change the size of our systems without impacting negatively the production of those units.
All right, makes sense. Thank you, Zach. I do appreciate that information.
Thank you very much for your time.
Awesome. Well, thank you for joining us for this consulting specifying engineer discussion about IAQ, a key topic within HVAC systems. We look forward to our next conversation. Thank you and goodbye.